Hello, and welcome to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Ethan Mueller.
Thank you, William. Welcome back to Tech. Today we're going to be discussing what happens when my solvent goes acid, from vapor degreasing to vacuum degreasing. And so this is a common thing that happens with solvent. Some solvents are worse offenders than others, but we're just going to talk about why it happens, how it happens, and how we fix it. So depending on the type of solvent that you're using, there is certainly a potential for it to go acidic. The chlorinated and brominated solvents tend to be the worst, NPB being a solvent that tends to go acidic more so than others. TCE can go acidic, your trans can go acidic. Methylene chloride, which is now going away, that can go acidic. But again, the NPB is probably going to be your worst offender. The grade of solvent that you're using, that factors in. A lot of these different solvents have grades and different blends that make them different products with various ingredients. And depending on which one you're using, it may have more of a tendency to go acid. So a big cause of your solvent becoming acid is thermal decomposition. And one of the main drivers of thermal decomposition is poor preventative maintenance. So essentially what happens is your equipment, you'll have heating elements in there, and potentially you're getting scale buildup or scum buildup on those elements, which insulates them and eventually can cause them to short out, which can create an arc. That arc can then thermally decompose that solvent, and from there you have kind of a feedback loop, if you will, where your solvent becomes more and more acidic as you delay dealing with it. Water is a big part of this. If you have water mixed in with your solvent, solvents do spit water out, but water in the process, that can be kind of a growth spot for acid. Essentially what's happening is that bromine atom or that chlorine atom is coming away and forming hydrochloric or hydrobromic acid. Stabilizers, a lot of these solvents are going to be, you're going to have some sort of process upkeep from your chemical supplier. They're going to say you need to add this stabilizer or this neutralizer, and not doing so will allow your solvent to become acidic. And so essentially what you're doing is you're trying to neutralize that acid as it's generated so that you're staying ahead of it and not getting to a place where it's going to be a problem for you. Again, this I kind of mentioned at the top, but process upkeep, keeping your machine clean, keeping your water separators emptied, your still bottoms clean. This is the type of thing that's going to help you prevent acid formation in your traditional open top vapor degreaser. So what happens when our solvent goes acidic? Is it a problem? Can I keep cleaning? That type of thing. You're definitely going to know when your bath has gone acid. You're going to see these rust slicks. It's going to start to get after the equipment, the components, and you'll see that just as a rust forms on the surface of your stainless steel. And eventually that can cause other problems, such as holes in your refrigeration or on your cooling coils. It'll eat those away. And so, yeah, can you keep cleaning? Yeah, you can probably clean, but you're maybe going to do damage to your parts. You're probably going to redeposit some of this rust on there. But your solvent should still be able to dissolve oils if you so choose. But realistically, the remedy, other than the prevention of acid and keeping up with those stabilizers and stuff, is you just got to dump and start fresh. So you dump out the solvent, dispose of it how you're supposed to dispose of it. Usually a waste handler will come and take that stuff away. And then you'll dump it, or you'll clean out your machine, and then you'll recharge it with fresh solvent and do your PMs to try to prevent that acid formation from reoccurring. Controlling acid formation is pretty straightforward. It's a lot about maintenance and doing the right things. Some of the products out there are going to have stabilizers or neutralizers. Following your chemical supplier's instructions on how to add those in at the right quantities, that's going to help you control acid in your system prior to it causing a problem. Maintaining your water separator and keeping your sump bottom clean, i.e. keeping your water separator empty, cleaning the gunk out, or having an offline distillation process take place to clean that solvent up. These are all things that are going to help you control the amount of acid that your process is generating. And so as a lot of these traditional open top vapor degreasing solvents become more restricted, more regulated, more expensive to operate, um, there's new emerging technology. This technology is not exactly new. It's been on the market for some time, but it's gaining all the time in popularity. And so this is solvent cleaning under vacuum degreasing technology. And just a quick overview, essentially what happens is you have a work chamber, you put parts in that work chamber, you close the door, you seal it, you pull a vacuum over the chamber. Solvent from tank one comes in. This is doing your gross cleaning, your removal of chips and fines and a gross majority of your oil. And it's cleaning and it goes back to tank one. Now tank two comes in, does a rinse, goes back to tank two. Tank three comes in, does the final rinse, goes back to tank three. Not every single machine has tanks 1, 2, and 3. There's all sorts of different configurations and different things you can do. But just as a general overview, tank 3 comes in, goes back, and all the while that solvent in tank 1 is being dosed to this distillation unit. And so that dirty solvent is going to the still is vaporizing it, sending it up as a hot vapor through a condenser, returning it to a liquid, where it then cascades down into tank 3, which cascades over to 2, which cascades over to 1, back to the still. And so it just goes in a nice big circle, constantly cleaning that solvent up and allowing you to reuse it. And you have very little emissive losses, unlike an open top traditional vapor degreaser, which is open to the atmosphere, and therefore you have a good amount of evaporative losses. There's two kinds of solvents that are used in these vacuum degreasers. Hydrocarbon, which is essentially mineral spirits, if you will. It's a long chain, hydrocarbon chain. And this is for cleaning non-polar things such as oils and grease. It works pretty good for that. Then we have modified alcohol, which is a unique molecule, a wonderful cleaning solvent. And it's for cleaning both polar and non-polar soils. So this will clean oil and grease and water-based coolants. There's a lot of benefits to vacuum degreasing. I won't get into all of them, but they're very efficient, very robust cleaning processes, and they have a low cost of operation, low overall cost of operation. Again, some more benefits of that. They have low operator environmental exposure, good cleaning, good drying, and overall low maintenance. These systems, the solvent in them do go acidic, similar to your solvents in your traditional open top degreasers. However, it's happening a little bit differently, where the molecule in those other is typically going acid or thermally decomposing. The solvent in this case isn't breaking down. What happens is you just have acid that is suspended within your solvent, and so it's mixing in. And so we can handle it a little bit differently. It doesn't need to go to that dump and recharge practice quite so quickly. So we want to routinely monitor this. Your chemical provider should have a kit. We have a test kit that we provide for our customers to monitor the acid. And then we have what we call a booster. Again, this is like a neutralizing agent or a scavenging agent that's scavenging for acid. And we have a table. So you do a titration and it tells you how much booster you need to dose into your machine. And so doing this routinely, doing this on a weekly or a bi-weekly basis, adding booster, as much as it's called for from the test, is going to help you keep that pH level where it needs to be and keep that acid out of your system, which in a vacuum system can cause some damage to your still bottom and your condenser and stuff like that. It's pretty simple to manage and prevent the acid that's coming into your vacuum system. Really, it's all about that preventative maintenance and your process upkeep. It just like in a vapor system, we're going to want to take our water separator. We're going to want to empty that routinely. We're going to want to keep our machine clean. These systems, again, there's total distillation cycles that you can run where it distills all the solvent in your machine. Um, Doing those routinely, emptying out your still bottoms after doing that, keeping this, getting the stuff out of the system as soon as possible. That's all really good practice. And then again, adding that booster in a regimen is it's very important, and it's very helpful for preventing acid damage and keeping your acid levels in check. And so this was kind of a short and sweet one, pretty straightforward topic, but the overall gist of the presentation, routine maintenance is the key to preventing acid from forming in your process. It's going to keep your equipment alive longer. It's going to keep your solvent costs down. It's going to keep your waste costs down. And so it's just good to maintain good maintenance on your machine. Vacuum degreasing, this isn't for everyone. Not everyone can adopt a vacuum degreaser, but in a lot of the situations where somebody was using like NPB or TCE or PERC, vacuum degreasing is a really good technology that is replacing some of those traditional cleaning processes, and it's making a more environmentally friendly, operator friendly, lower cost of operation cleaning process. And so it's really something worth investigating if you're looking at a new cleaning process. And if you're using something like PERC, this is probably going to be the technology is going to be reminiscent of what you were using, but you might need new equipment. So just a couple of frequently asked questions before we wrap it up and I turn it back over to William. Will fluorinated solvent go acid? So typically your brominated solvents, your NPB is going to be the worst offender of going acid. Your chlorinated solvents, your TCE, your trans blends, those are going to have a potential to go acidic. And then your fluorinated solvents are going to, it's unlikely that they'll go acidic, but they can go acidic. So most likely if you're using a fluorinated product, your chemical supplier isn't going to be providing you with instructions and products for stabilizing the acid. Can I remedy solvent that has gone acidic? When we're talking vacuum degreasers, yes, absolutely. You can add booster, and it just takes some time for that solvent to cycle back through the whole entire process and get that booster mixed through the system. But yeah, you can get your solvent back to a good pH where you don't have to dump and recharge. In the open top degreasers, the NPBs, the TCEs, when those have gone acidic, it's much harder to come back from. Your best case scenario is to, again, dump that solvent out, get rid of it, clean out your machine really good, and then put in fresh solvent. What is the problem with acid? So the problem with acid is pretty straightforward. It's equipment damage. There's a lot of susceptible components, especially on an open top vapor degreaser, that are susceptible to acid. Your still bottoms go out. Your cooling coils go out, you get holes in your refrigeration, and that can be costly, or that can totally ruin your equipment to where you may be buying a brand new piece of equipment. Can I avoid acid altogether? If your process generates acid, other than in the case of thermal decomposition where you're getting that arc from your heating element, it's unlikely that you're going to be able to avoid the generation of acid in your process. But again, it's all about that preventative maintenance and staying in front of it, adding your stabilizers, adding your boosters, keeping your machine clean, keeping your water separator empty. All those things are going to help you minimize the amount of acid that you have to deal with, and therefore minimize the effects of it. And with that, I thank you for joining, and I will turn it back over to William.
Thanks, Ethan. Thank you guys for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech tech@KYZEN.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.